Welcome back. There are a ton of programming languages out there. We've heard of them, right? Python, Ruby, Java, C++. There's a ton. And although JavaScript is the dominant language on the web, and with the introduction of things like Node.js, we can now use JavaScript outside of the web, perhaps in the backend server as well. The world still has many different languages that are suited for their own domain and ability. And if we had to categorize all these programming languages somehow, we would probably do something like this. In this video, we're going to talk about the main spectrum here, the dynamic and static of how programming languages can differ. Dynamically typed and statically typed. We see over here that JavaScript is a dynamically typed language, and so are other popular programming languages like PHP, Ruby, Python, Clojure. On the other hand, languages like Java, Haskell, Scala, C++ are static or statically typed languages. But what does that mean? Well, let me actually just demonstrate it for you. If I open up the console here, and that's a nice background today. Anyway, back to the console so we can type some JavaScript. In JavaScript, because it's dynamically typed, we can do something like this. Variable a equals 100. All right, that's pretty expected. We know how JavaScript works, and that's fine. But in some languages, this wouldn't work. You see, a dynamically typed language allows us to not have to say what type of variable this variable a is going to be. What does that mean? Well, in a statically typed language, let's say we were writing C++, which is a statically typed language, we'd have to do something like this. And I won't get highlighting because, well, this browser won't recognize C++. But if I was about to do the same thing, I would have to say int a, and int stands for an integer. And then on a new line, I'll say, let me add a semicolon here. And on a new line, I'd say that a equals 100. You see, with a statically typed language, I have to say what kind of type this variable is going to be. In this case, it's an integer. If this was a string, like a hello, I'd have to say string, and so on and so forth. So with a statically typed language, we have to declare the variables explicitly before using them. Dynamically typed languages are not bound to this constraint. They're not bound to a particular type. JavaScript is smart enough, and it's going to say, yes, variable a, that's 100. Oh yeah, that's an integer. It's an integer type. Wow, I'm so smart. That's what JavaScript is saying. And in dynamically typed languages, type checking is done during runtime. What does that mean? Well, if you remember in our discussion about the browser performance, JavaScript gets run on the browser in the runtime, or in JIT, or just-in-time compilation. While the user is actually browsing through the website, JavaScript is running and being compiled in the background. If you remember our performance tab, we had our scripting performance metric, which was that yellow pie graph, or the piece of the pie graph that was yellow, that included the compile of the JavaScript as well. And because of that, we're able to use dynamically typed languages that can assign anything to any variable, and you're not going to be caught. You might get errors during runtime while the user is browsing your website, but because of this, we're able to just not have to worry about this. Looks pretty nice, right? Why would we ever want to do this? This is just so much cleaner and easier for us to write. Well, we're going to see why that might not always be ideal and why it might cause a problem. But before we get to that, There's been a holy war going on in programming languages. People that think statically typed languages are the way to go and think dynamically typed languages are horrible, and vice versa. People that say, oh, statically typed languages are a waste of time and dynamic programming languages are the way to go. Because of that, I'm treading lightly on this topic because people are so opinionated. They have such strong opinions about this. But again, as senior developers, let's not focus on what is right, what is wrong. Let's focus on pros and cons, when one is good over the other, so that we can make smart decisions. Let's talk about the pros. The number one thing with a statically typed language like this is that we get documentation. Perhaps a better way to demonstrate this is to actually write a function. If, let's say, I was going to delete this and say function sum, and in this sum here, I'm going to use a bit of a syntax that might not be familiar to you, but for now, it's fine. We'll just assume that this works. We'll say A is a number, and B is also a number. And in here, we can just return A plus B and close our function bracket. This is in JavaScript. If we ran this, we're going to get an error. But this demonstrates what a statically typed language could do. You see, if a new developer came along and ran the sum function with something other than a number, let's say that they ran the sum function with sum hello and maybe something null. Well, this, before we're ever even going to put this code on the browser or in production, is going to error out because it's going to say, you're doing something wrong here. I'm expecting a number and a number here, and you're not giving me any of that. And in that sense, statically typed languages are self-documenting. That is, I can come onto a project and immediately see that even if this was named badly and this was a complicated function, I can see what kind of parameters it expects, and I avoid making that error. The second pro of a static typed language is that because of this feature, with our IDEs or text editors like Sublime or Visual Code or any of your favorite text editor, this helps with autocompletion in your editors. You can download plugins that say, hey, even before you run this, this should be a number. That's also really nice when you're developing. Finally, the most important thing, and yes, there are many more pros, but we're just focusing on the main ones here. The main thing of statically typed languages is that you're going to get less bugs. You're going to get less bugs in production because this will never make it into production. If this fails at what we call compile time, that is, before we even send it onto a browser, then we catch that early. We catch those bugs early so that in production, most of the time, there's going to be less bugs with a statically typed language. And don't worry, we're going to talk about compiling and how that works later on. Now, that sounds pretty great. Less bugs, easy documentation, helpful autocompletion in editors. So why don't we just do a statically typed language? Well, there's some cons. Number one is that we obviously just made our code a little bit more harder to read. It's more complex now. We're just adding another layer to our programs. And this takes time to learn. If we have our project and we have new people joining our company, we're going to have to teach them how to write more code and how to write this properly. It's an extra layer of complexity. And that's always a concern with programming, right? Adding an extra layer of complexity, is that really going to benefit the project? The other cons or argument against statically typed languages is that, well, why can't you just write better tests? A topic that we cover in another section. Many people get very, very excited about static typing and forget about writing good tests, good unit tests. Before you have static typing, especially in a language like JavaScript, make sure that you have good unit tests and you don't forget about writing unit tests and assume, oh yeah, just because I have static typing, I'm not going to get any bugs. That simply isn't true. Finally, with a statically typed language, you're going to have a slower development process because you now have an extra step where while you're coding along, there's also another check to see that you're not making any type errors. And this actually just slows down the development process and how fast you can create code and run code and ship it to production. You see, with dynamically typed languages, and this is why JavaScript was so popular, is that you spend less time debugging syntax and semantic errors like this, and instead, most of your debugging time is spent purely on logic and errors, which, as a developer, are a lot more interesting. All right, let's go back to this. There are a few other pros and cons, and everybody always has opinions when it comes to these two topics. But the main point is this. Static types usually prevent bugs and help keep errors from happening. Dynamic typing allows you to be more flexible and write software faster. TypeScript allows us to make JavaScript to behave like a statically typed language. It adds types to JavaScript. So it makes JavaScript extra safe. But before I go on and show you a demonstration of how TypeScript works, let's talk about the other two parts of this graph that often get confused with dynamic and static typing. I'll see you in the next one. Bye-bye.